Okay, so here we're going to take a look at factor by grouping with 4 or more terms. All right, so whenever you start with 4, or you'll see on the next page even more terms, what we want to do is first you want to look and say, well, do I have a greatest common factor that I could factor out of each term? Okay, that's always your first step with factoring no matter what. So when you look at this expression, we can't. So what we're going to do is we're going to just take the first two terms and we're going to group them together. And we're going to take the last two terms and group them together. And we're going to look and say, well, what can I pull out of these first two terms, right? What's the GCF out of these first two terms? Well, I could pull out a 5 as well as an x squared. So I'm going to pull out a 5x squared, and then in parentheses, we're going to write what we're left with. Okay, so we're just factoring out the greatest common factor. Okay, so 10 divided by 5 is 2. And then we had 3 x's, and we took 2 of them out, so there's still an x to put in here. And then we bring down our plus sign. 15 divided by 5 is 3. And we had 2 x's, right, x squared. We took them both out, so we have none left to put here, so we're going to close our parentheses. Okay, so now let's look at our next two terms. We have an 8x and a 12. So the biggest number that divides evenly into both of them is a 4. Okay, so we're going to pull out a positive 4. And when we do, right, and remember you guys have done factor by grouping before. Remember, you have to have this sign here. If you just write 4, it means times 4. That's not what we're doing. We're adding on 4 times what goes in this parenthesis. So without that plus sign, unfortunately, the expression is not equivalent to what we see above. All right, so 8x divided by 4 would be 2x. And then 12 divided by 4 would be 3. Okay, and then if you remember, we take what's in front of our common parenthesis here, and we group them together as our first factor. So 5x squared plus 4. And then we take our common parenthesis, right, the 2x plus 3, and we write it once and once only. And you do want to look and say, can I factor further? But whenever you have two terms, if there's no subtraction sign here, you're really not looking for dots. And if you couldn't take out a GCF from the beginning, you're not going to be able to do so now. So that's it. We're fully factored. All right, let's take a look here at number 44. Okay, so in this example, we're not going to just jump right into factor by grouping. Look at these numbers, right? We can pull out a greatest common factor. We could factor out a 2 from each of those terms. So when we do, it leaves us with 2x cubed minus 4x squared plus 3x minus 6. Okay, now what we're going to do is this 2 is just going to keep coming down, right? And I'm going to open a parenthesis. I know some people like to put a square bracket. You can do that as well. It really means the same thing. Now, we're going to group together our first two terms and then group together the second two terms. Okay, so out of the first two terms, we could pull out a 2 and then an x squared. And when we do, that's going to leave us with x minus 2. Okay, out of these next two terms, we could pull out a positive 3. And remember, when deciding whether to factor out a positive or a negative, you want to factor out whatever is going to leave you with the same thing in parentheses. So since positive 3x divided by positive 3 gives you positive x, right? See how that's a positive x? You want those to match up. And then negative 6 divided by positive 3 is negative 2. That's what we have here. We want that to match up. Okay, and then I have to close this parenthesis, but I also have to close this one as well. Okay, so now this 2 comes down. And if you recall, we grouped together the 2x squared and the plus 3. Right, we grouped together what's in front of these two parentheses. And that is one of our factors. And then we rewrite that common, the common expression we see in those parentheses, once and once only. All right, so this right here is factored. I mean, you do want to look and say, can we factor further? But as long as you've already pulled out the greatest common factor, the only thing we're looking for is dots, and neither one of those is a difference of 2 squares. Okay, so now I'm going to jump down here to number 48. Now, when you look at number 48, what you'll notice is, again, just like the last one, look, you can factor out a greatest common factor. All right, this time we could factor out a 4. And that's going to leave us with 1x cubed minus 4 plus 2x squared minus 2x. Okay, so I'm going to bring this 4 down, open my parentheses, and when I group the first two terms, well, the only thing I could pull out is a 1. And when I do, it leaves me with x cubed minus 4. Okay, now out of the next two terms, I could pull out a 2x. And when I do, that leaves me with an x minus 1. Okay, so now we see we have a problem, right? Because isn't what's in this parenthesis supposed to match what's in this parenthesis? And they don't. All right, so that means one of two things. Number one, actually one of three things. Number one, we made a mistake. Number two, this just doesn't factor by grouping. Or number three, let's go back and look at our terms. Sometimes you have to rearrange your terms, right? Reorder them so that you can do factor by grouping. Now, if you look at this original expression, see how it goes from x to the third to x to the 0 to x squared to x to the first? This is not written in what we call standard form. Okay, I'm going to backtrack. So hopefully you're using pencil, right? So we can erase. And if you're using pen, I guess you're going to have a big X through your problem, which is okay. It's okay to show that, in your notes that it didn't work when we tried it as is. So what I'm going to actually just erase, and I'm going to go all the way back to the very beginning. Okay, so I'm going to first rewrite this expression in standard form. And when I say standard form, it means I'm going to put the variables with the biggest exponents first, and it's going to work its way down in descending order. Okay, so isn't x to the third the biggest exponent we have on these x's? So I'm first going to write 4x to the third. Okay, then as I look, the next biggest one is right here, 8x squared. Okay, and then 8x to the first. Now there's a negative in front of this, so make sure when you write it, we write minus 8x to the first. And then we have just this number hanging out here by itself, so negative 16. It really means negative 16x to the 0 power, right? If you want to look at your exponents, x to the third, x to the second, x to the first, and this would be x to the 0. So I'm going to write minus 16. Okay, and then from here, we're going to just, again, factor out that 4, which leaves me with x cubed plus 2x squared minus 2x minus 4. And then this 4 comes down, and we're going to jump into grouping. Okay, so to the first two terms, I could factor out an x squared, which leaves me with x plus 2. Out of the next two terms, you want to decide, do I want to factor out a negative 2 or a positive 2? Well, if I want to be left with a positive x and a positive 2 in parentheses, well, I'm going to factor out the negative 2. Okay, and then that'll leave me with positive x and positive 2. Okay, because a negative divided by a negative is positive, and again, negative divided by negative is positive. And don't forget to double close those parentheses. Okay, so then let's just take our 4 and bring it down. I'm going to group together the x squared minus 2. And then I'm going to rewrite that common parenthesis just once. And again, I want to look and say, can I factor further? Okay, when I have two terms, is it a difference of perfect squares? Well, no, because 2 is not a perfect square, so this would be our final answer. Okay, so we're going to take a look at a couple examples on the next page. Now, if you look at the first one, what you'll notice is we have 6 terms. And when we do grouping, you just want to make groups of equal amounts of terms. So with 6 terms, you could do really one of two things. You could either factor it into 2 groups of 3, or you could factor it into 3 groups of 2. And sometimes you may have to try them both to see which factoring technique works. Okay, let me show you what I mean by that. So let's start off with, the first thing I said is we could do 2 groups of 3. Okay, you just want to create even groups here. So they have the same amount of terms in each group. Okay, so watch what happens. So now out of the first 3 terms, the only thing I could pull out is really k squared, I guess. 1k squared. So when I do, it's going to leave me with k squared minus 4 plus 8k, which that's not in standard form within the parentheses, so we may have to rearrange that later. Okay, out of the next 3 terms, well, it looks like the most you could factor out really is just a negative 4, which would leave me with a positive 8k, and then a negative 3k squared, and then negative 48 divided by negative 4 is positive 12. Now what you'll notice is, look at this, these parentheses don't match, okay? So this wasn't the method that, works. So what we're gonna do is, instead of making 2 groups of 3, we're gonna try 3 groups of 2. As long as they have the same number of terms in each group, you can give it a shot. Okay, so out of these first 2 terms, we could factor out a k squared, which is going to leave me with k squared minus 4. Out of the next 2 terms, we could factor out an 8 as well as a k. So I'm going to factor out a positive 8k. And that's going to leave me with k squared and then minus 4. So far, so good. Look, these are matching up. Okay, so now out of these last 2 terms, we could factor out a positive 12. And look at that. That's also going to leave us with a k squared and a minus 4. So since all these parentheses match up, it means we're on the right track. So just like we do with, other examples with factor by grouping, we're going to take what's in front of our common parentheses, and we're going to group them together as one of our factors. Okay, so our first factor is going to say k squared plus 8k plus 12. And it's okay that there's 3 terms. It's okay that it's a trinomial. And then we're going to take this common parenthesis and rewrite it just once. All right, now, some of you may be looking at this and saying, wait, look, we can totally factor further, and you're right. Okay, so let's start with this. When you have a trinomial, if the leading coefficient is 1, remember, we don't do the rainbow. We set up 2 sets of parentheses. If this is a k squared, we're going to put a k here and here, right? Because k times k gives you k squared. All right, and then we want to come up with 2 numbers that add to 8 and multiply to 12. So positive 6 and positive 2. So we put that here and here. Okay, and then if we look here, this factors further too. This is a difference of 2 squares. Okay, so when we have that, we set up 2 sets of parentheses. One gets an addition and one gets a subtraction. And we put the square root of this first term in the first spot in each parenthesis. So the square root of k squared is k. And we put the square root of the second term in the second spot in each parenthesis. So the square root of 4 is 2. And if you look, we cannot factor further, so this would be our final answer. And I just want to point out, and I'm going to say or, another way you could write this is, since we have 2 of the same factors, if you want to write it once and put a square on it, you can. So what I mean is, you could bring down the k plus 6, and you could put your factors in any order you want. Since we have 2 of the k plus 2's, we could write it once with a square on it, and then we can bring down the k minus 2. And that is another way to write our answer. Okay, we're going to take a look at one last one, and it's going to be number 51. Okay, so again, we have 6 terms. So we have to decide, do we want to break it up into 3 groups of 2, or do we want to break it up into 2 groups of 3? Now, as you get, more familiar with these, a lot of you will be able to look at it and say, well, it makes sense to do this. So a lot of you will be able to look at it and say, that's what's going to leave me with the same terms within the parentheses. So, I'm looking ahead. We have a 1, 5, 6, 1, 5, 6. So to me, it makes the most sense to group this into 2 groups of 3. I'm thinking that's going to get us the same expression within the parentheses. But if you're not sure, just try it out. Try doing it into 3 groups of 2. And if that doesn't work, then do 2 groups of 3. Okay, so I'm going to start with 2 groups of 3 because I'm thinking that's going to work. So if I look at these first 3 terms, I could factor out an m. And when I do, it leaves me with m squared plus 5m plus 6. Okay, now out of these last 3 terms, the only thing we could factor out is a 1. And you do have to put the 1, and not just a 1, you have to write plus 1. Okay, and then that's going to leave us with, if you factor out a 1, it leaves you with the same exact expression as what you started with. So what you'll notice is that, look at this, our parentheses match. So I'm going to take the m and the plus 1, and I'm going to group that together into a parenthesis as our first factor. And then I'm going to write this common expression, right, the common parenthesis, just once. Now we do want to look and say, can we factor further? And what you'll notice is this you cannot. This is a trinomial. So as long as we can come up with 2 numbers that add to the middle term and multiply to the last term, then we can factor it further. And we can, right? Isn't 3 plus 2, 5? And 3 times 2, 6. So we can break this up into m, and well, since this is an m squared, right? The square root of m squared is m. I'm going to put an m here and here. And then again, the 2 numbers that multiply to 6 and add to 5 were positive 3 and positive 2. So positive 3 and positive 2, in whatever order you want to put them, it totally does not matter. And then don't forget about this factor hanging out. This has to come down as well. So we wind up with 3 factors in the end.